This is Euclid Book 10, proposition number 6. Okay, and here is the illustration, right here. Okay. If two magnitudes have to one another the ratio which a number has to a number, the magnitudes will be commensurable. For let the two magnitudes A and B have to one another the ratio which the number D has to the number E. Okay. So what Euclid is saying here is as A is to B, so will D be to E. That's what he's saying. I say that the magnitudes A and B are commensurable. For let A be divided into as many equal parts as there are units in D. So if there are 3 units in D, A will be divided into 3 equal parts. Okay? And let C be equal to one of those parts of A. Okay, so the length of C is the same length as one part of A. And let F be made up of as many magnitudes equal to C as there are units in E. Okay, so F is also subdivided, okay, and each piece of F is going to be the same length as C. Okay. So let's say that we divide F into 4 equal parts. Well, each one of those parts is going to be exactly the same size as E. Since then there are in A as many magnitudes equal to C as there are units in D. Whatever part of the unit is of D, the same part is C of A also. Therefore, as C is to A, so is the unit is to D. As C is to A, so is 1 is to D. That's what Euclid's saying. Okay. This is by Euclid Book 7, definition number 20. But the unit measures the number D. Therefore, C also measures A. Now we're saying that since 1 measures D, C measures A. That's what we're saying. And since as C is to A, so is the unit is to D, therefore inversely, as A is to C, so is the number D to the unit. So, as A is to C, so as D is to 1. This is by Euclid Book 5, proposition number 7, chorism. Again, since there are in F as many magnitudes equal to C as there are units in E, therefore, as C is to F, okay, so is 1 is to E. As C is to F, so is 1 is to E. Okay. And this is by Euclid Book 7, definition number 20. But it was also proved that as A is to C, so as D is to the unit. We already said that A is to C as D is to 1. Okay. Therefore, xi quali as A is to F, so as D is to E. As A is to F, so as D is to E. And this is by Euclid Book 5, proposition number 22. But as D is to E, so as A is to B. As D is to E, so as A is to B. Therefore, also, as A is to B, so it is to F also. Okay? So as A is to B, so as A is to F. As A is to B, so as A is to F. That's what they're saying. This is by Euclid Book 5, proposition number 11. Therefore, A has the same ratio to each of the magnitudes B and F. Okay? So as A is to B, so as A is to F. Okay? Therefore, B is equal to F. Now we're going to say that B is the same length as F. And this is by Euclid Book 5, proposition number 9. But C measures F. Now we're going to say that C measures F. Okay? Therefore, C measures B. If C measures F, then C will also measure B. Okay. Now, C also measures A. C measures A. Therefore, C measures A and B. Therefore, A is commensurable with B. It says A and B have a common measure, which is C, then A and B are commensurable. Alright, now we come to yet another porism. From this, it is manifest that if there be two numbers as D and E, and a straight line as A, it is possible to make a straight line F such that the given straight line is to it as the number D is to the number E. And if a mean proportional be also taken between A and F and B, as A is to F, so will the square on A be to the square on B. So in other words, as A is to F, if you were to find A squared, and you were also able to find, hang on, okay, as A is to F, if you were to find the square of A and B, then as A is to F, so would the square of A be the square of B. That's what he's saying. Okay? That is, as the first is to the third, so the figure on the first to that which is similar and similarly described on the second. This is by Euclid Book 6, proposition number 19, porism. But as A is to F, so is the number D is to the number E. Therefore, it has been contrived that as the number D is to the number E, so also the figure on the straight line A is to the figure on the straight line B. So, what they're saying here is as D is to E, so is A squared is to B squared. That's what they're saying. Or what Euclid's saying anyway. That's a lot. That's a lot of things for Euclid to say. Alright, I will tell you more in my next video. Stay tuned.